Hello all, this is group 6. We are doing fake news detection using machine learning algorithms. We are the team members Akhil Boga, Bharat Posa, Chandrasekhar Kandur and Monica Dontireddy. And the next slide, nowadays we can see that fake news has been a major issue in this connect world. There is a misinformation related to Snapchat caused a significant loss for Snapdeal. However, it's certainly possible for misinformation and fake news to cause harm to business. So we can detect using machine learning algorithms this type of business problem. In the next slide, we are discussing about the data set. That data set consists of three columns, which are label, text, and text tag. And the label is the target variable. It has 6 unique values ranging from 0 to 5. And also text column contains statements or claims that are fact checked. And a text tag is this is the one or more labels tags for each statement which is available in the data set. In the next slide, here we can see the sample image of the data set and labels, text and text tag column. And this is our prediction labels. 0 indicates less likely to be true, 1 indicates false, and 2 indicates partially truth, 3 indicates more likely to be true, 4 indicates unknown, and last one 5 indicates truth. Here we can see the plotted frequency distribution for target column. It looks pretty quite balanced. So we can proceed to apply these labels to our machine learning algorithms. In the next slide, we can see the architecture of our project. First, we have loaded the data set. It is in the CSV format. Then we do the data pre-processing and data cleaning and data pre-processing. After it is done, we will give our data to the model training and the checking accuracy. Based on the accuracy, we have saved the model in pickle file, and you can see that we have developed our application in web app. So in the architecture, we can see that we have developed user interface. We can give response and we can give request and take the response from whether it is fake news or partially truth or more likely be true. Like this, we can detect using this architecture. My contribution towards the project is backend ML model processing and integrating with UI sentence transformers. And the next, Akhil Boga.
Uh, this is Akhil Boga, and I'll be explaining about the design phase for this project. So for the initial phase, we'll be choosing a desired data set, which is like feasible to be implemented in our machine learning model. And in the second phase, we'll be doing an exploratory data analysis for the data set. And then we'll be implementing a data cleanup to remove the stop words and the null values and everything. Then we have this feature extraction methods such as bag of words, TF-IDF to extract the features for the model building. And then next, we develop models for each of them, and then data pre-processing techniques. Then we apply the hyperparameter tuning for all the models. Then we also use strong cross-validation methods to avoid underfitting as well as overfitting. Then in this stage, we combine all the predictions hence made to make our model robust and then efficient. Coming to the data cleaning process, we'll be removing the null values, and then we'll be removing the stop words as well as replacing the punctuations with spaces. And then we'll be doing the stemming process, like we'll be making the derived words to their base forms. So we'll be also be using for the data pre-processing, we'll be using bag of words, TF-IDF, and then transformers. And the models that we have used are KNN, SVM, Naive Bayes, XGBoost, CatBoost, and Multi-Naive Bayes. So for the results of bag of words, when using the bag of words model with the KNN, we have gained an accuracy of 48%, upon which we have experimented with the SVC model, which gained us 84%. Then we proceeded with doing tryouts with the XGBoost model, which gained us some 55%. Further models will be explained by Monica.
Hi, this is Monica. So coming to TF-IDF, so when we perform TF-IDF on the results, so we got around 70%, 74% uh, by implementing naive Bayes. And after that, we have performed LGMC classifier, uh, out of which we obtained like 0.67 like 67%. And after performing XG boost on that, we obtained around 69%. So after that, we have performed cat boost for the above results. So for that, we have obtained 44%. So by using cat boost and the transformers, so we got the accuracy around 96%. Yep. Yeah. Later will be continued by Bharat. And my contribution for this project is like I have performed data cleaning, data processing, reprocessing, and web CSS. Thank you.
Hi, in this project, in this we built a web application in order to deploy the highest performing model into a web application so that people can use it. So the tech stack we used here is Python, SQL, scikit-learn, HTML, Flask, and Ajax. Um, if you see the model deployment pipeline, whatever the model that we have developed, the cat boost one, which so we saved it in a pickle file. We developed a web application that can read the model, and then we created a web interface that can read the request and then send a response for that. And then if we stop the web server, we can terminate the entire application. That's the overall flow. So if you see this one, the UI, you can see that there is a checkbox to enter the text that you want to check the factness, and you can click the other button to check a new for a new one. In the next slide, here this is the one factoid which says that Hillary Clinton in 2005 co-sponsored for the legislation that would jail flag burners, which is actually a truth. So when we checked it, we got it as a truth. Then if you we changed the sentence a bit with the Joe Biden, so which says that Joe Biden with flag burners, which it stated it as false. And in the next model, we got a Hillary Clinton sponsored legislation that would jail flag burners. But this is likely to be true. But here you can see the difference between the factoidal truth with the most likely to be true. Yeah. And we have used references using these papers while developing this model. And the last we found that the transformers model made the most accuracy. And my contribution here is like I worked with the model development. Along with that, I also built the application for the deployment. Thank you.
This is Akhil Boga, and my contributions are model selection, training, and improving the model accuracy. Thank you.